So in the development of surfaces is of two type. One is parallel line method, another one is radial line method. So if you take parallel line method, it is applicable only for prism and solids, that is for cylinders. Similarly, if you take in the case of radial line method, this is applicable only for pyramids and cones. So if you take in the case of prism and cylinder, if you take prism, how it looks like, your bottom and the top is looks like a same shape. If you take in the case of cylinder also, your bottom and top may be of same shape. If you take in the case of prism, it may be a square prism, or it may be a pentagonal prism, or it may be an hexagonal prism. If you take in the case of cylinder, it is a cylindrical circle object on the top and bottom. This is what our parallel lines can be applicable to these two conditions, that is prism condition and cylinder condition. If you take in the case of prism and cylinder condition, the development of length, that is your development of length L, can be calculated by these two formulas. Please take down this. These two formulas are useful for you to develop your length over here. So that the development length is considered to be L. L is equal to number of sides, that is total number of sides. If you take pentagon prism, it has, that is pentagonal prism or else hexagonal prism, it has 6 face or it may be a 5 face. So the 6 face and 5 face have 6 sides and 5 sides. So over here we will consider how many sides, either 5 or 6, and the side distance. This side distance is the length of your system, where we will solve when you can able to understand about the condition L. Similarly, if you take in the case of cylinder, L is equal to pi into d, that is pi is your 3.14 into diameter. Then if you take in the case of radial line method, it is applicable only for pyramids and cones. So if you take in the case of pyramid, it may be a square pyramid, or it may be a pentagonal pyramid, or it may be a hexagonal pyramid. Like I will show here. If you take in the case of pyramid, it may be a square pyramid, or it may be an pentagonal and hexagonal pyramid. Like three types are possible with this. But if you take in the case of cone, it is of only one classification, that is it is a circle type. Okay, so if you take in the case of this one, for parallel line method, prism and cylinder, prism means the top and bottom may be of a square, a pentagon or hexagon. If you take cylinder, it will be like a circular object on the top and bottom. If you take radial line method, the pyramid and cone, the pyramid may be square pyramid or pentagonal pyramid or hexagonal pyramid, but the cone, the base will be in circle. But if you take in the case of pyramids and cones, your apex will be a single point. Your base may be of 4 sides, 5 sides or 6 sides or circular, but on the top you will be connected to only one point, that is called an apex point. Okay, so over here the true line of the slantage, when you connect to to a single point, you can able to develop a true line. Based on the true line only, you can able to develop the development line. So for pyramid, the L is true length of the slantage. For all the pyramids, the true length of your slantage is the condition. But if you take in the case of cone, theta is equal to R by L into 360. That is the length of the true length of the slantage, and R is the radius of the circle. So theta is equal to R by L into 360. So with this formula only, we can able to develop the development section of our drawings. Okay, so please take down this. With this four conditions only, we are going to proceed for prism and cylinder parallel line method. For pyramid and cone, we are going to follow the radial line method. So these are the four major methods to develop your length, that is your development length. Shall I move to next slide? Okay, now take down the problem. An hexagonal prism of base side 25 mm and axis length 55 mm is resting on HP, and one of its base with two of the vertical faces perpendicular to VP. It is cut by a plane. It is cut by a plane inclined at 50 degree to VP and perpendicular, that is 50 degree to HP and perpendicular to VP, and passing through a point at a distance 12 mm from the top base. So they ask you to draw the development of lateral surface of the solid. Okay, so we are clear over here that in the question they have provided prism. Okay, so if you take in the case of prism, the only method is what? Parallel line method. Okay, so if they provided prism means it is parallel line method. Okay, which represents your bottom and top have the same shape. Okay, so over here hexagonal prism, for hexagonal prism how many sides? How many sides for hexagonal prism? 6 sides. Okay, so over here for the sixth side, for each side we are going to consider 25 mm and axis length as 55 mm. They also mention that it is resting on the HP on one of its base with two of the vertical faces perpendicular to VP. Now we are going to start the drawing. Okay. Now first we will start our XY plane. Okay. I'm going to start my XY plane. This is my XY plane, so I'm going to consider this as X and this side as Y. Okay, then followed by this is VP and this is HP. Okay, so in your question they have provided the prism of base side 25 mm. Okay, so prism of base side 25 mm, we are going to develop our hexagonal prism. I'm going to develop my hexagonal prism now. So in this hexagonal prism I am going to measure my so in your question they have provided 25 mm, so we can develop our prism for 25 mm. So can you able to find this 25 mm now? Okay, this may be an approximate one for the 25 mm now. Okay, so this is your 25 mm of hexagonal prism. I am going to place it over here and we can name it this as, we start naming the prism by considering this is my point A, this is my point B, and this is my point C, this is my point D, this is my point E, this is my point F. Okay, so A, B, C, D, E, F. Now on the other side of your, this is maybe your top view, so your bottom view you will have another one side, we are representing that as P. You can just write over here itself, A of P as the first point, B of Q as your second point, then C of R as your third point, then D of S. Is the problem is completed last time itself? You can just repeat once again today also. just for practice. Then yes, over here we can consider T, and we can consider this as Q. Okay, then followed by we can extend our reference lines. Okay, so let us extend the reference line from here, then from this point, and we can develop from this point. Okay, so after developing this, we know in your question it is provided that the length as 55 mm. Now we are going to consider a 55 mm of length. So I have measured over here, keep it in this point and rotate it and take this as 25, that is 55 mm. Similarly, keep it over here and measure it, cut here an arc, then followed by keep it over here, then so then cut an arc. So now we are going to develop our front view. For developing the front view, we consider from this point to, that is from this point to here, then from this point to here, and marking with this point with this one. Okay, so after this we can able to find that your surface is developed. Okay, so now what we are going to do is that we are going to mark it by means of your representation. For making this representation, I am going to consider this as P dash of U dash. Okay, then followed by the second point is Q dash of T dash. Then the third point, R dash of S dash. Then on the top is your A dash of F dash, A dash of F dash. Then over here B dash of E dash. Then over here C dash of D dash. Okay, so we have marked everything over here, the representation. Then in this question they are given that it is cut by an plane inclined at 50° to HP and perpendicular to VP and passing through a point at a distance of 12 mm from the top base. So from the top base we are going to cut it for 12 mm for our section. So we have to consider 12 mm and keep it on the axis, rotate it and cut an arc. So now we have developed the cutting plane condition, and now we are going to mark it with 50 degrees. So in your question they have provided we need to mark it for 50°. Okay, so this is my 50°. I put a mark over here. Sorry, I just put a mark over here, 50°. Okay, after this marking of 50°, we will consider a line has been passing in this condition. Okay, this is your cutting plane. So we are going to represent the cutting plane as V and T. Okay, we are going to represent the cutting plane as B over here and T on the other side. This is your cutting plane condition. So now we can develop the true shape of your objects. Okay, so in this you can able to find your top face of 12 mm from your top base where it cuts an horizontal line on the surface. So we want to consider this section also. That means from this point, sorry, from this point we have the cutting condition. So we can do the original view now of your object. So starting from here to here is your original object, that is this is the object after your cutting plane you can able to find. Then from here to here and from here to here, then followed by this one, and from this point to, sorry, from here to here, then from this point to this point. Similarly, this is your true shape condition. Okay, this is your true shape condition. Now in this true shape condition we can do the hatch. So this is your sectioned object from the top view. This is your sectioned object. That means this part alone we have section. The remaining this part is available. This is the remaining available part over here. Okay. Now we can start marking the dimension. For marking the dimension we can take yellow lines. Consider from this to this one, then from this plane condition to here, then my cut plane from here. Now we are going to represent our dimension. For representing the dimension, what is the dimension over here, then what is your cutting plane dimension from the top surface, and what is your height of your cylinder. So for this we will consider our one side of your prism base is 25 mm, so we can consider this as 25. Just place it over here. Then followed by the height of your cylinder, that is your prism, is considered to be 55. Then followed by our cutting plane condition is 12 mm from the top. Okay, then we want to mark the dimension of it. That means what is the dimension of this angle. So this angle is nearly 50 degree. Okay, so I'm going to write this as 50 degree. Okay, so here the angle will be 50 degree. So after this we want to develop our condition over here. Okay, so after this we can mark how our cutting planes are. So I'm going to consider my first cutting plane as 1. This is my 1. Okay, that is 1 dash, 1 dash. Then this is my 2 dash, my second point. Then 3 dash my third point, then followed by 4 dash over here, then my 5 dash over here, and 6 dash over here. So as early we have said that this is a prism type. For prism type we can use the formula L is equal to number of sides into side distance. So over here the development of section L is equal to number of sides into what? Number of sides into base side distance. Okay, so you will consider L equal to, over here how many sides? 6 sides into 6 sides into your length of the axis is 55. This is your length. So what will be the answer for this? L equal to, what is the length over here? What is the length condition over here? Is that right? Is that right? No, I am asking is the formula is right. L is equal to number of sides into length. Then what it will be? Number of sides into length is equal to number of sides into what you will consider? Either height of your cylinder or base side. Base side, that is 25 mm. If you put that, what is the value? 150 mm. Okay, so this is important one. You want to show this calculation during your exam, then only it will be awarded. Because if you consider 150 mm without this calculation, they may not award you the mark. Please do this calculation and show the what is the formula used. Either if you take in the case of this one, this is an hexagonal prism, so you can directly use. If you take a cone, you want to mention theta is equal to r by l into 360, then only you can able to proceed with the problem solving. Okay, so over here we can consider that is 6 sides into 25 base. That means we are going to open this 25 over here, which is equal to 150. So now I am going to keep my scale over here and I am going to mark where is my starting point and ending point. Okay, now first I am going to consider this as my starting point. I will take some. This is my starting point over here. Now what is the next distance I want to mark? Anyone? For this development of section, what is the next distance I want to mark? What is the next distance? I consider 0 as my first point. What is the next point of my side? 15 or 25? 6 into 25. So this is my second point. 50, 75, 100, then 125, then followed by 150. Okay, so if you just plot like this, means you can able to easily complete the problem in a short time. Or else for each time you want to take your pencil and you want to mark over here. Now we can start developing our reference lines from this points. I'm starting my first reference plane, my second reference point, my third reference point. Okay, I'm taking my third reference point. This is my fourth reference point, then fifth reference point, sixth reference point, and my last ending point. Okay, so now what we are going to do is that we know the height of our system is how much? 55. So from this point I am going to develop a line so that I can able to understand my drawing has to be completed within this line. That is, within this line I want to complete my drawing. Now what we are going to do is that we are going to mark what are the faces over here for your understanding. Okay, so first point we can able to see PQRSPU. Okay, so I'm going to write over here as my P as the first point, then Q as my second point, then followed by R as my third point, S as my fourth point, then T as my then U as my next point, and last ending once again with P as my closing point. Okay, when you start from this point where you can able to find it is closing over here only, on the top what shall we do? We will mark this as A, that is A. Over here I mark this as B, then this as C, this as D, then next point as E, then the next point as F, then the closing point as once again A. Okay, if you miss this A and P point, your drawing will not be completed. So you want to mark this line and you want to mark how it is closing. Okay, now what we are going to do is that we are going to take our compass and keep it over here on the first point. Consider for 1 until what height you have. So this is my first one. Okay, so I am going to keep it over here, that is on my PQ line, and I am going to cut the arc. I'm going to cut the arc here. Okay, now for second one, going to place it over here, and I am going to measure my second point. Okay, for second point I am going to keep it on Q, and I am going to cut an arc, sorry, cut an arc over here. Then once again I am going to keep it over here, that is my third point. Okay, for this I prefer you to measure first what is the distance between your axis and your true position condition. Okay, for this you can just move the compass, measure this two distance. Okay, then keep it over here at what distance it will be, then cut an arc for your reference only, this one. Okay, then followed by develop an reference line from this point to here, so that you can easily understand what is the distance of your cutting on the third point. Okay, so now keep it over here, then move your compass and measure the top side, measure the top side. Okay, where you can able to find it cuts on the same axis, that is it cuts on the top position. Okay, then followed by for your next condition also you can able to see the C is in the top condition, so here also you will get the same one like this. Then followed by for D you can able to find it is also in the top condition, so I am just marking over here itself. Then for E what happens? Then for E it starts to change based on the cutting condition. Okay, now I'm going to consider over here, keep it on T point, then develop an arc over here. Then once again you want to keep for F. So for F, this is the condition, keep it on U, then cut an arc. Similarly for P also the same way. Okay, so now we can connect all these points. For connecting these points I'm going to consider, okay, I'm going to consider a dark line. So this is my, so from here one point, then from this point is your second one, then this is your cutting plane point, this is your cutting plane point. If you want you can show this line, or else you can go with the reference line. Only thing is that we will connect these two lines over here, the fourth line, then fifth point line, this is your sixth point line, and this is the last closing line. Okay, now what we are going to do is that we are going to consider our points by connecting all this. Then this is the connection between these two, and this is the connection between these 2 points. After this we are going to connect from here to here. Can you able to understand now? You can directly connect this point. Similarly, if you take this one also, it will connect moreover on the same condition. Okay, over here. Okay. Then followed by we can mark what are the points on your cutting. So we have marked 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. So we can mark over here, this is your first point. Okay, then this is your second point, then this is your third point, then this is your fourth point. Okay, then this is your fifth point, and this is your sixth point, and this is your seventh point, and this is the last one, that is your eighth point. Okay, so this is the drawing completion stage. Okay, in this we want to show two major distance. That means one distance is between 25, how it is represented. So I am going to represent by, from this point, what is the distance between these two, then what is the entire length distance you want to mark over here. Okay, for that I am going to represent between these two lines what is the dimension, and between this point and the last one what is the dimension. Okay, for this the first one will be how much, 25. So your base side is 25, so you surely will get your distance as 25. Similarly, the entire length you have calculated as 150. I'm going to keep it over here. So after completing this drawing, you want to mention all dimensions are in mm. Okay, all dimensions are in mm. Then followed by, like our previous section of solids, we have mentioned what are the views we have developed. Similarly, you want to develop over here also what are the true conditions. That means what are the views you have developed. For that you can mention over here as top view, and over here as front view, and on the other as development view or development of lateral surface of the solid, development of lateral surface of the solid. Okay, so this is your end diagram for development of pentagonal prism. Okay, so with the given data. So anyone is having any doubt on this?